Welcome to our statistics review video. These don't really go into questions, just more vocabulary that I heard some confusion with this week or the past few weeks, and also just kind of a recap where I should be studying perhaps, or maybe if I have some questions, because it's Tuesday I'm posting this, so maybe by the end of the week you've kind of caught up any of these concepts that you're like, this is what I'm stuck with. You can now identify the concept that we can focus on together in tutoring. Okay, so some prior knowledge that y'all should have come in with from elementary school probability and statistics and middle school probability and statistics and potentially algebra 1 or algebra 2 probability and statistics. So a data set contains information on the individual. Most of us are kind of picking up on this process. What is the individual? But where I see the confusion is that some of us are taking the individual, including it as a variable. So please remember that there is a difference between your individual and your variable. And some of you guys are saying, well, okay, if this is my individual, then all of my variables, including the individual, are the variables I'm going to talk about. But in reality, let's make that separation between the two. Okay, variables can be both categorical or quantitative. Some variables have an opportunity to be both, but not in the data set. For example, the most common one that I see is for year. So if my year is in 2009 and 2010 and 2017 and whatever, then this would be quantitative data. But if I say, years are the 80s and the 90s and the 2000s, then this would be a categorical data because it's a category. It is a genre of decade, I guess you could say. But let's make sure that we're identifying that. I saw that on your week one quiz is that quite a few of us interpreted the year as a category instead of an actual quantitative data. Okay, the distribution of a variable describes what values it takes and how often it takes them. So in that individual variable set, what's going on, how frequent do we see that information, blah, 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 blah. Okay, and inference is the process of making a conclusion. What we've learned in the past couple of weeks is that we can infer, but what is a formal inference? And then I gave you all those amazing acronyms that we're going to do in this class. We're going to cuss and we're going to BS. So please, 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 as you're doing your formal inferences, you need to have information about center. You need to have information about your unusuals, even if you've calculated and there's nothing, shape, and spread. And so as we started this, some of us, we're bridging some knowledge gap and we're getting to that vocabulary. And so now I think as we go through, you guys are like, okay, what is my center? Where are my high points? Where is everything clustered around? So I've seen some of those great vocabulary words. Unusual. Are there funky gaps? Are there outliers? Your shape, that's that skew right, skew left, roughly symmetric. How do I understand that? Is it simply based off of a graph? Is it based off of my data? Is it a combination of both? Do I look at my median mode? So ask yourself these questions. Spread, that's the one that I see us skip the most, mainly because we kind of got to analysis with numbers a little bit later on. But remember, spread can be my range, it can be the standard deviation, it can be any of those kinds of information. And then that BS is just that little phrase that just reminds us to be specific. So you guys have been doing a really great job of this all week, is that your sentences, when it's necessary, it includes all the information that was given to you. So again, y'all have gotten into this habit, but repeat. Always repeat. What you were given, you want to repeat in your sentences. Do I always have to write a complete sentence? No. You're looking for keywords. Some keywords, this is not all of them, could be explain, describe, show me how, blah, 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 blah. So use those keywords when you're looking about AP statistics questions. Use those keywords to let you know if you really need to have a descriptive sentence or if it's just the information and the work they want. So moving into the actual stuff we learned the past couple of weeks. So chapter 1.1, analyzing categorical data. This was kind of our easiest section. We did what was a bar graph, why can categorical data be deceptive? So it was a really good question. What makes a graph deceptive? And so y'all saw a question like that on the quiz. It was like, Billy did a graph and what was wrong with it. And so the big thing that y'all notice is that the range was crazy. It went from 0 to 80 and then 80 to 100 and then 100. So the scaling was off. And so that could be one reason that categorical data can be deceptive. There's a few others. So I'm just giving you kind of hints what to think about, what to look for, what to process from your notes and all of our work. Describe the association between two categorical variables. So that's just recognizing, can I infer? Can I not infer? Is it enough information? Is it not enough information? Even though I see a strong association, it doesn't necessarily mean that there is a relationship between them. So kind of recognizing what is an inference, what is a formal inference in statistics. Okay, so this is one I know we struggled with. Ms. Jag, what is a marginal distribution versus a categorical distribution? So let's see this. So recall two-way tables. Y'all know two-way tables means you got rows and columns, and you have at least two variables. Okay, so you got those two different variables. In this instance, we've got females and we've got males. Okay, so what about marginal distribution? The simplest way I can tell you is I can't speak. I'm so sorry. Marginal distribution is going to be just like a kind of a summary total of all the individuals. But let me give you that visually because it's so much easier if we see it. So here's a little, how do I do it? Use the data, make the graph. Okay, but I've got this same young adults by gender. So what if I want to know the marginal distribution? First and foremost, marginal tells me I'm going to need to look at them in percents. So am I going to look at the females? No, because that's just one part. Am I going to look at the males? No, that's just one part. So I'm looking at the total of both of my variables, and I'm going to look at their percent. So here's the percent calculation. 194 out of 4,826. 712 out of and you get your percents based off of that. From there, we can create our graph, our bar graph, and from here, now we can actually see that distribution by all of my variables. Both males, both females, what is their chance of being wealthy? And it is in percent, so it's a parts of a whole, so it's a little easier to analyze that data. Okay, but where we can actually see what is marginal distribution is where we see the versus. Marginal versus our conditional distribution. So conditional distribution is you're looking at a specific variable. In our example, that's female or male. So what if I want to know the conditional distribution of the female? So I'm going to select, make my data, do the graph. So part one is the only thing that's different between marginal and categorical is that selection of row or column of interest. In this case, we want to know side-by-side segmented. Okay, so that's my second difference. I forgot. How you display it's going to be a little different because now you're going to show two variables in this example. We're going to show both the female and the male. So first I start by looking at the distribution of just the male. Then I do the distribution of just the female. Okay, and so now I can create, in this case, it's that segmented or stacked bar graph. You could have done a side-by-side, and that's okay too. They're both equally valid. And so now we've got that conditional distribution. So now, unlike the marginal distribution, that was just chance of being wealthy by age 30. Now I can see a relationship. Do males have a higher chance? Do females have a higher chance? I can use comparison language. Greater than, less than, equal to, roughly equal. I can use comparison language because you have two categories, two variables you're actually comparing. So it's my biggest difference between marginal distribution, the whole, conditional distribution, portion. So by variable or by row. Okay. So moving on to the next section we talked about, which was displaying. So again, all about the visuals. So dot plots, stem plots. What about describing overall pattern of distribution? So again, cusp, yes. Identifying the shape, making and interpreting histograms, comparing distributions of quantitative data. I felt like this was some of the easiest stuff we've done the past few weeks, so I'm not really going to go into any of that. But in our third section, where we actually did it with numbers, I feel like we had some confusion. So let me hit on some points. Calculating mean, median, mode. You guys have figured that out, I think. Identifying the outliers using the 1.5 times the times the IQR rule. Again, I think we've figured that out. Using appropriate graphs to compare distributions or appropriate summaries to compare distributions. Again, as we work through practice problems, I'm starting to see y'all make appropriate connections. But here is where I see. Calculate this measures of spread. Great. What are measures of spread? Range, IQR, standard deviation. I'm telling you those now, so next time you answer a spread question, you're like, oh, right, range, IQR, standard deviation. But what about the interpretation? So we've got travel times for 20 New Yorkers. And so we find the IQR. First, we do a little 5-number summary. So there's my median, my Q1, my Q3. You can see my max and my min on my table. So we get our IQR. And now let's interpret the IQR. That's the word I'm hinging on, is the interpretation. I think some of us struggle with it. So here is the full sentence. The range of the middle half of travel times for the New Yorkers in the sample is 27.5 minutes. That's the interpretation. And that one sentence kind of stumped some of us. So I'm showing you an example. Start to modify whenever it says, find and interpret. That's the sentence. That's the key word. The interpret is the full sentence they were looking for. Moving on to the other thing I want to talk about, the interpretation of box plots. There was some disconnect, not on how to make a box plot, but there was a disconnect on how do I adjust the outlier for that max min. So let me show you what we should do. So what happens when I have a max min? Same data, same median, Q1, and Q3. We can see our minimum and our maximum are 5 and still 85. However, because we know this is an outlier, and you can do the math yourself if you don't trust me, but because we know that 85 is an outlier, is that really where my whisker ends? Is that 85? We know the answer is no. We have to represent it on the outside. So what is the number of the whisker? And so somebody asked me, is that just the next lowest value? And it's the next lowest value inside your range that still fits within your outlier rule. So I just want to make sure I make that very clear. And so I want to show you a visual aid of this. So now there's your Q1, there's your median, there's your Q3. My whisker on the left end happens to be my minimum value of 5, but my whisker on my right end is not going to be 85. It's going to be the next smallest number, which is 65, which is inside our IQR times 1.5 range. From there, I simply place my outlier on the outside and ta-da. So I saw some questions. I heard some questions the past couple weeks about this, so I wanted to make sure I showcase that. And the last two things I want to talk about are choosing the most appropriate measure of center and spread. This one, some of you guys are like, okay, what's the most appropriate measure of center? And you guys are like, the median. Or some of you immediately, the mean. There's no correct answer. You must assess your data. So it is the most appropriate measure of center is data specific. There will never be a just general answer for everyone, but I can give you some hints and tricks. So what are our measures of center and spread? Mean, standard deviation, median, interquartile range. So center tends to be mean and median. Spread tends to be standard deviation and interquartile range. Well, they are, but where can I use my best value? So the median and the IQ are usually better than the mean and standard deviation when you have a skewed distribution or a distribution with outliers. But again, it says usually better, not a hard and fast rule. It's a general suggestion. It tends to be this. Use mean and standard deviation only for reasonably symmetric distributions that don't have an outlier. Okay. For some of you who are like, okay, well, I trust in these rules, but I don't understand these rules, we can talk. Maybe see me. I'm hoping that just by reading it and you think about the visual description that they're talking about, thinking about a skewed or something that has major outliers, think about what that data does and why median would be better if it was skewed or all over the place, and why mean would be better if it was pretty symmetric. I want you to think about that. If we need to have that conversation, we absolutely can, but that's a really good thinking point. Okay, numerical summaries do not fully describe the shape of your distribution. Always plot. Okay, so here's that proof. You cannot just make assumptions. Your data is where you get your inferences from. Alrighty, so test is on Friday. Good luck and study hard.